Okay, boys and girls, today is Module 1, Lesson 1. We're going to be working with the Say 10 way and adding 10. Here we go. This is the hundreds chart. You probably remember this from kindergarten and first grade. It's a way to organize numbers from 1 to 100 in rows of 10. So the top row has 10, the next row will have 10. And if you notice on the right-hand side, this column over here that is dark, those numbers are counting by 10. 10, 20, 30, 40, and so on all the way to 100, okay? So when using our hundreds chart, we start over here on the left-hand side and we count across the entire top row. When we get to the end, then we go to below. Now, you'll notice that this number 10 over here can be represented using place value cubes. This is a 10 stick. Now, you may wonder why we call that a 10 stick, and I'm going to tell you. It's because it is composed of 10 single cubes. This is one cube. So as we're counting, we are counting by individual ones. So we say 1, which is represented by 1 cube. Then we go to 2, which would be represented by 2 cubes. 3, represented by 3 cubes, and so on. When we get to 10, we say we have 1 10, or this 10 stick that looks like this, okay? Now, we can represent all numbers on the hundreds chart using place value blocks. Let's look at the number 13 as another example. 13 is represented by 110. Do you see this digit 1 right here? That represents 110. Here's our group of 10. And it has 3 ones. 1, 2, 3. So the number 13 is 110 and 3 ones. That's what it's worth. That's the value of the number 13. 110, 3 ones. So when we're counting using the hundreds chart, we can count by saying the digit's name, like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and so on till we get to 100. There's another way we can count that we're going to practice today. It's the Say 10 way. When we count the Say 10 way, we say how many groups of 10 are in that number. So I'm going to demonstrate how you count the Say 10 way. We would start here again with 1. 1, 2, 3, 4, 5, 6, 7, 8, 9, 110. Now, I said 110 because 10 is represented by one group of 10. When I get down to the next row, instead of saying 11, I'll say 110, 1, 110, 2, 110, 3. The reason I'm saying 110 is that the number 13 has one group of 10 and 3 ones. Let's keep going. 110, 4, 110, 5, 110, 6, 110, 7, 110, 8, 110, 9, and 2 tens. Now 20, the number 20, is represented with 2 tens. This number 2, the 2 digit, is 2 tens, and this 0 represents 0 ones. So we can say the number 20, or we could say 2 tens. I want you to practice counting the Say 10 way with me, okay? So here we go. Let's count together. We're going to start with the number 1, and we're going to stop right here when we get to the number 20, or when we say 2 tens. Here we go. 1, 2, 3, 4, 5, 6, 7, 8, 9, 110. 110, 1, 110, 2, 110, 3, 110, 4, 110, 5, 110, 6, 110, 7, 110, 8, 110, 9, 2 tens. Did you do it? Were you able to count the Say 10 way? Good work. Let's look at the number 15. This is the number 15. We can show 15 using our place value cubes by getting 110. Here, this number, this digit represents one group of 10, and 5 ones. The number on the right here, this digit 5, represents the 5 ones in 15. So 15 is 110 plus 5 ones equals 15. Now, you may remember these symbols, and I hope you do. This is the addition symbol, and this is the equal symbol. So when we see this little plus sign, we're adding these two parts together. When we see this symbol, the equal symbol, it means equals or the same. So whatever is on this side is the same or equivalent or equal to what is on the other side of that symbol. Okay, those are the different ways 15 can be represented. Let's check out another number. Let's do the number 17. Now, 17 with our place value blocks is represented with 110. Right here, it has 110 and 7 ones. Okay? You may recognize this. This is a number bond. Now, we can put numbers on the number bond to show how numbers can break apart and represent them on the number bond as well. So let's do the number 17. Here's the number 17. It's our whole. That's the total. That's the number we're working with. The number 17 can be broke down into the parts. Tens, which this one has 110, which is one group of 10 equals 10. And the ones, 7 ones. So when we put 17 in a number bond, two parts could be 10 and 7. And those two parts together equal the whole, which is 17. So we can say 10 plus 7 equals 17. 17 is 110, 7 ones. These are the parts of 17. We have 10 and we have 7. Here's one part, 10. Here's another part, 7. When we put this addition symbol between them, we're going to add them together. And when we add them together, we get this part right here, which is the whole. 17, that's the whole. Now, you're going to get a chance to add numbers to 10 today. Here are two parts of one number. We have 10 plus, which means we're going to be adding them together, 5 equals. That's what we're trying to solve, okay? Here's our number bond. Now, we're going to plug in the parts that we know. We know we have 110, and we know that we have 5 ones. We're going to add these together. So let's think about this. We have 110 and we have 5 ones. What number is created with 110 and 5 ones? If you said 15, you're correct. 10 plus 5 equals 15. The number 15 has 110 and 5 ones. Okay, let's look at another number, sentence, or equation here. Now this one looks different. Can you tell what's different? Up here I have my parts on this side. I have 10 plus 5, and 10 and 5 are my two parts. Then I have my equal symbol, and I have a line for my whole. This is the whole. Down here, the equation is set up a little differently. You'll notice that I have this blank space right here. This is where the whole for this equation is going to go. Then I have my equal symbol, which means that this part over here and this part over here have to equal the same amount. They have to be the same. They have to be equivalent or equal, okay? And then here are my two parts, 10 plus 2. So even though I switched the location of the parts and the whole, we're still going to add them together. Let's get a number bond up here. You'll notice my number bond almost looks like it fell over, like it's tipped on its side. It doesn't matter which way the number bond stands. It could stand upright like this one, or it could be tipped on its side like this one. It still has a whole and two parts, okay? So let's look at this equation we have. We have one part being 10. Here's 10. We know we have 10. Well, the other part is 2. So we have 10 plus 2. Our two parts are 10 and 2. Now we're going to try and solve this. So if we have 1 10 and 2 1s, what is our total? What is the whole? If you said 12, you're correct. 12 is represented with 1 10, which is this group right here. It's one part. Here's our 1 10, and our 2 1s represented over here in this part. 10 plus 2 equals 12. Or we could say it like this. 12 equals 10 plus 2. Now, I want you to look at the last number sentence or equation that I have here at the bottom. This one looks a little bit interesting. Right here, I have the number 10. And then I have, let's go back to my previous slide. Here I have the number 10. And then I have this space here, and it equals 19. This definitely looks different than the other two equations we just worked on. So we're going to go to the next slide and take a closer look at this equation or number sentence that we have. So here we have the number 10. We have our addition plus symbol here. Then we're actually missing a part. Do you notice that one of the parts is missing? Then we have the equal sign, and then we have our whole right here, 19. So we have to look at what we know. Here's our number bond. One thing we know is the whole or the total. We know that this equation, whatever part is missing, is going to equal 19 when it's added to this 10. So our whole or our total is 19. Here's 19. Here's 19 in our number bond. That's the total or the whole. So the number here, when it's added to this number, cannot be more than 19 because 19 is the total or the whole. Now we know that one part is 10. So we put that part down here in the number bond. We have one part is 10 and we have a whole of 19. What are we trying to find? That's right. We're trying to find the other part that is missing. So let's look at our place value blocks. This 1 in 19 represents 110, which is the part that's right here or right here. So this 10 place value stick is representing the part we know, or this one digit that you see in the number 19. That represents 110. So we have to ask ourselves, what is missing? Look at the number 19. If we know the part that's 10, what is the part we don't know? If you said the 9 1s, you're correct. This digit 9 represents 9 1s. The number 19 is composed of those two parts, 110 and 9 1s. So we could say that 19 is made of 110 and 9 1s. Together, the whole is 19. So 10 plus, what was our missing part? 9 equals 19. You're going to get a chance to practice this today on Seesaw. So once you've watched this video, you're going to go back to Seesaw and you're going to have a chance to solve adding to 10. So you'll see some activities for you on Seesaw that practices the skills that we just practiced here in this video. So return to Seesaw and you can complete your math assignment.